All right, so someone had a question from Chapter 8, Section 3, and it's dealing with proportions and finding p-values and test statistics. So if we're looking at 5 different colors of candies, the same proportion of candies that are green. So we're looking for the ones that are green. There's a claim that 17% of them are green. So use the data in the table to find the p-value and the significance level, 0.025. So that is our alpha. So I need to see how many are green. Now, it looks like they're giving me a table of the weights of the... See if I can get this to pop up. The weights of the candies, and I really don't care about the weights in this particular problem. I care about the number of them that are green. So, waiting for this to pop up. It's going to happen. And it finally happened. So if I'm looking at these, I see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 here that are green. Now I don't know how many there are. I'm curious if I could just open this in StatCrunch and see if it'll help me out on that. So here's the data in StatCrunch. And if I just wanted to get a count of all these so I don't have to count them, well, this is kind of nice because I know that there's 16, 22, 15, 15, and 13. So that wouldn't be too bad to just add those values up. Doesn't seem too rigorous. Get out my calculator and say 16 plus 22 plus 2 15s plus a 13. So I see that there's 81, right? So I have a total of 81, but there's 15 green ones. I tried opening up my calculator. It just took a long time, so I went old school with it. So 15 out of the 8 of 1 are green. So I'm going to do a proportion statistics. I have one sample. I have a summary of the data. There's 15 out of the 81. And I should be able to find what I'm looking for with this. So successes were 15 out of 81. The bleed proportion, let's go back and answer this very first question. So, hold on. There we are. So the null, it's believed that it's 17%. We're trying to see if we think it's different or greater than or less than. And looking at this, I don't see anything that says greater than or less than, so I just have to assume not equal to. So if it's believed that it's equal to 17%, my alternative hypothesis would believe that it's not equal to 70%. So we'll check that answer, and hopefully we'll get a nice high five from my math lab. And there's our high five. What is the test statistic? Well, I'm going to go back over here and I'm going to find my test statistic. Because I'm doing a hypothesis test where it's equal to 0.17 versus not equal to 0.17. And that's all I have to do. I hit compute and I'm going to get this test statistic they're going to give me in StatCrunch. Once it thinks for a second. here's my test statistic to 2 decimal places is 0.36. So let's go over here. We'll get a 0.36 in there. And we'll check that. And looks good. And then they're going to probably ask for a p-value. Going back to that, my p-value is 0.716. And we will check that. And it should like that as well. And then we're probably going to have to make a conclusion. What we're going to be comparing this to is our alpha of 0.025. So the phrase goes, as I've said in other videos, if the P is low, the hoe gotta go. And so we're comparing our p-value to our alpha. If the p-value is lower than our alpha, is 0.716 smaller than 0.025? It is not. So that means that if the p is lower than the alpha, then the hoe gotta go. The alternative or the null hypothesis has to go. Ours is not lower, so that means we keep the null hypothesis, right? So we believe that this is true. So we fail to reject the null hypothesis because the p-value is greater than the significance level of alpha. So it looks like we're picking a D on this one. So if the p is low, we reject. But if the p is not lower than the alpha, we fail to reject. And that should give us the big old high five here in a second. So I hope that helps with this one. Again, as you have questions, please let me know.